told you that no matter who you are or where you are, you can participate in science at NASA and make real-world discoveries alongside NASA scientists. Hello, I'm your host, Emily Ferfaro, and this is another virtual episode of NASA Science Live. From mapping the ocean floors to discovering new planets outside of our solar system, NASA has so many different citizen science projects where members of the public actually collaborate with NASA scientists to make amazing discoveries together. NASA's chief scientist, Jim Green, is here to tell us more.
Have you ever had an aha moment? That feeling when everything just seems to make sense. Scientists have them all the time. Hi, I'm Jim Green, NASA's chief scientist, and I have discovered many new things in my career. And let me tell you, there's nothing quite like that feeling when you discover something important that no one in the world knows. What if I told you that through NASA's Citizen Science program, you too can experience that same feeling? Are you interested? Citizen scientists working with NASA have made many significant discoveries, some of them right from their own home. For instance, 54,000 circumstellar disks have been found by citizen scientists. What are they? These are debris fields around stars in our galaxy where planets are being formed for the very first time. What about the citizen scientists that have discovered 18,000 mosquito breeding sites in NASA Earth Science images? Breeding sites like these are important to first find since mosquitoes carry all sorts of diseases. So there are many other discoveries going on in NASA's citizen science projects, and you can get involved. These projects are real collaborations between scientists and an interested public like you. I am sure some of you might be saying, well, I don't have a fancy degree, or I can't discover new planets beyond our solar system. And you'd be wrong. You don't have to have a special degree or job title. In fact, you don't even need to have experience. If you're curious about our universe and about our planet Earth, you can get involved with real NASA projects and work alongside real scientists right now. So what are you waiting for? Come on and join us. To get started, go to science.nasa.gov/citizenscience. See you there.
I don't know about you, but hearing about the discoveries made by citizen scientists is so exciting. If you're anything like me, science was always interesting, but I never thought I could be a scientist. So it was great to hear Dr. Green talk about how anyone can get involved with these projects and make discoveries. There are so many great projects that you can get involved with. Today on the show, we'll talk about a few, but if you want to learn about all of the opportunities, visit science.nasa.gov/citizenscience. Did you know that planets form from vast clouds of gas, dust, and chunks of rock? Clouds that are in the shape of disks with stars at the center. By searching for stars that are surrounded by these cloud disks, we can find out where planets are currently forming and where other planets probably exist today. Finding these planet-forming disks has been a major quest of astronomers for the past 3 decades. Through a project called Disk Detective, you can help. We're joined today by Dr. Mark Kushner, Citizen Science Officer at NASA headquarters, and citizen scientist Hugo Durantini Luca. Thank you so much for being with us today.
Thanks, Emily.
Thank you.
So Mark, can you tell us a little bit more about Disk Detective? Why does NASA need help studying these objects?
So NASA has a wonderful problem, which is that we have images of the whole sky at infrared wavelengths, and the images from NASA's WISE mission, the Wide Field Infrared Explorer, contain 2 billion sources. And which of those sources are the planet-forming disks? That's where we go to members of the public and ask for their help, figuring out which of those needles in the haystack is a real planet-forming disk.
Wow. Wow. That is amazing that real people can help with this type of research. Hugo, you are one of those people. So what has been the most exciting part about working on this project?
For in this moment is like a compilation of things since I am participating since 2014. At the start for me was finding a project where I was able to participate and contribute with science and be engaged at the same time because I was trying a couple of things in that point, but they were fun projects and all, but they were no interaction with the science thing, for example. And when I started to interact with Mark via Twitter in that point, I started to learn about the project and talk back and forth with the science team. I was able to be interact with the project because that interaction was engaging. So I was able to contribute at the same time. I was learning about the project, how the project worked, how the people working in the project was. Um, that was a very important thing at first because I didn't know much about astronomy at that point. I was able to find astronomy but didn't know about the subject. So be able to participate and learn and reach the discovery like the Peter Pan disc for this detective was something huge. I was not even thinking into discovery at that point, maybe. I was only thinking in participate and be able to contribute in an active way.
And
Wow.
we've been learning from you too, Hugo. It's been a wonderful 6 years working together with you. I feel so fortunate to be able to meet the citizen scientists that we've met through this project.
Yeah, it seems like such a great community. So can anyone get involved and help with this project? What sort of experience do people need?
No experience necessary. So you just go to diskdetective.org. There's a short online tutorial. In about 5 minutes, you're looking at data, you're helping NASA, and you're potentially making discoveries.
Indeed. And remember, you are going to be having fun while learning. So be patient. If the project really caught your attention, you are going to have much time to learn about more details and different parts of the project. So have a try and have fun.
That's awesome. That's such good advice. That was actually going to be my next question. What sort of advice do you have for people that might be interested in getting started?
In astronomy, patience is one of the key because astronomy have a lot of different things, a lot of tools and surveys and catalogs and vocabulary to learn. That patience is one of the keys aside of wanting to learn. And astronomy have also a huge variety of things to study. Maybe you want to know to look at stars, perfect. Or maybe you want to see pretty galaxies. There are also projects for that. Astronomy, can you have a big selection of things for you there?
And Hugo, you helped us discover Peter Pan disks, which are the oldest disks that are still forming planets. So scientists, we astronomers thought that disks stopped forming planets after about 5 million years, but then the citizen scientists at Disk Detective started finding objects that were able to form planets about 9 or 10 times the age of that, so into the 40 and 50 million year old age range. And the astronomy community is still trying to figure out what that means. So it's pretty exciting.
That's
Yeah.
amazing. That is so cool that new discoveries have come out of this, working with citizens and scientists.
Yeah, and maybe for people participating, can leave some surprise. Like me, when I was invited to my local TV station to do an interview about that, well, you became a local celebrity for a bit by making a science discovery.
That is so cool. Wow. Well, that's all the time we have today. Thank you both so much for joining us.
Thanks for having us, Emily.
Thank you for having us. It'll be a
Yes,
pleasure.
of course. Using the power of our global community, NASA has developed an interactive app called NemoNet. It's used to characterize coral reef ecosystems around the world with unprecedented accuracy. Today, we're joined by 10-year-old citizen scientist Kellen Homan and NASA scientist Dr. Ved Tarayath to tell us more about this fun project. Thank you both for joining us today. Ved, so can you tell us a little bit more about NemoNet? What is it?
Sure. So I invented a technology called fluid lensing at NASA, and it's the first technique we've had that can look beneath the ocean waves and map corals in 3D. So we've been traveling around the world using drones and this technique to map corals in 3D. And the biggest challenge we have with all of this data is how to classify it. How do we get the basic number of how many corals there are, how they're doing as a function of changing ocean temperatures? And that's where NemoNet comes in. So we built a video game that ties into our supercomputer, and you can download it and play it on your iPhone or iPad device. And what you're doing in that game is looking at our data sets that we are getting from around the world with these drones and helping learn about corals at the same time as coloring them and feeding data into our supercomputer.
Wow, this is such a cool idea to get people involved in this project. Kellen, I understand that you've been working on this project. So can you tell us, is NemoNet more like a game or is it like schoolwork? And have you learned science by playing the game?
It's kind of like a game because it's not schoolwork. You kind of get to do what you want to do. You can choose where you want to be and what you want to do. There's like 2D, 3D, and then there's stuff like that.
That sounds very fun. What kind of things have you learned from playing the game?
There's a lot of different types of coral, and there are some key regions that have coral. They are... You can classify Guam, the Great Barrier Reef, American Samoa, Hawaii, or Puerto Rico coral. So that seems like where the most of the coral is probably.
Wow, I didn't know that. So can you show us kind of how you interact with this app? I hear that you are so good at classifying coral that you have earned the status of sea turtle. Was it hard to get to that level?
Yep, I've been playing it for a few months now. So I have my 3D map of coral. I have the types of coral on here. I can hold this, and then I can go to a list of all the coral types I have, what I can classify, and like what they look like. So then I'll get out of that, and then we have the 3D map too. You can like scroll all the directions. You can look from like all directions.
It sounds like you're a pro. So Ved, how are citizen scientists like Kellen and their work in this app helping us understand what's going on with coral reefs?
To put it bluntly, they are changing the world. We have mapped, as of 2020, around 6% of the ocean floor. And one of the reasons why it's so difficult to map the ocean floor first is because it's difficult to see anything beneath ocean waves. So our instrument helps fix that and reveal that environment in 3D. But the second is once you have all that data, it really doesn't mean anything unless you have humans come in and help annotate what it is we're looking at. Is it sand? Are we looking at sea cucumbers, seagrass, corals? And it really becomes a complicated machine learning problem. So when we first created the project, we didn't have a video game in mind. We were purely focused on supercomputing and being able to develop the tool to classify these reefs. But we learned, that the supercomputer results and the machine learning outputs were only as good as the training data we have. And at that point, we thought, all right, we have an untapped potential across the world, in our nation as well, with all of these students who are interested, engaged, they want to explore these environments. It's funny that this happened during the pandemic, and a lot of folks were looking for an activity to do at home that would be at once educational and benefit science, and that's when we decided to launch NemoNet on Earth Day this year. And so we currently have around 100,000 plus active users. Kellen is in our top 1% of pro players. He outclassifies PhD trained coral reef biologists regularly. His screen name is Admiral Crocodile, and it's really just amazing how quickly kids in his age group pick up on classifying. And this is not an easy task. I struggle with this. You open the game, you see a 3D coral, which looks like a loaf of bread to some people. It can look like very different shapes. Kids have to learn what that is, pass an accuracy test while painting in 3D, and that's how they graduate and level up the food chain in the video game. And all of that data then gets compared on our supercomputer. We can measure its statistics related to other scientists' inputs, other amateur players, and it's really the sweet spot we found for classification is roughly Kellen's age group. and the amount of time that they play, the knowledge they have in these environments is really just extraordinary. So yeah, I would say we could not do it without kids like Kellen.
This is so amazing. So, Kellen, do you have any advice for people watching that might want to get involved?
Yeah, I also want to, where I actually have the number, there have been 73,588 classifications by everybody who's been playing NemoNet.
That's amazing.
And advice is definitely take your time and do it one at a time. And definitely look and make sure you know what each coral type looks like, because they do give actual pictures in the game of what the coral types look like. So that helps classify when you can see what the coral type looks like, and then you can put that into your knowledge of what you're looking for in the game.
This is so cool. I am just so impressed, but thank you both so much for joining us. Let's move up into the atmosphere, way up to where the auroras dance across our skies. In order to track the appearance of auroras across the globe, NASA supports a citizen science project called Aurorasaurus, where volunteers submit reports and photographs through a mobile app and website. With all of this data from users around the planet, researchers are able to learn more about this mysterious and dazzling phenomenon. I'm joined by NASA scientist Dr. Elizabeth McDonald and citizen scientist Donna Locke. Thank you so much for joining us.
Hi, thank you for including me.
Hi, thanks.
Of course. So, Elizabeth, why is it an important area of research to have these citizen scientists contribute regarding auroras?
Yeah, so auroras affect our technologies on Earth and in the sky in satellites, and they move really quickly, and it's important to get an understanding of what they're doing, even when they're really quiet or really large, and citizen scientists can really help with that.
Amazing. So, Donna, you are a citizen scientist with this project. Can you kind of walk us through what contributing looks like?
Sure. What Aurorasaurus wants is our observations from the ground wherever we are. So we are their boots on the ground, eyes to the sky. And it starts with me watching the forecasts for the aurora and the solar activity, listening to the chatter on Twitter and our Facebook groups. And when the conditions are right and the sky is clear, I head out with my camera and I will take pictures of the aurora. And after that, I will report by going online to Aurorasaurus or on their app, but we would give them our observations and upload a photo of what we saw on the ground.
Wow. And Elizabeth, how does that help you with your research?
Well, knowing exactly what time it was and where the person was when they saw the aurora allows us to put all of those different images together along with our traditional observations and understand the phenomena in more depth.
What kind of discoveries have citizen scientists made with this project?
So one big one is something called Steve, which is actually an aurora that can be seen further away from the poles than the usual aurora. So overhead over southern Canada and the northern US. And it's very unusual. It kind of looks like an airplane condensation trail, but with a photograph, you can pick up these amazing colors as well. And by studying it further with satellite data and other data from the ground, we've discovered it's really like a flow-driven aurora. It's an east to west flow that is lighting up the sky and doing some amazing kind of new, unusual auroral activity that's still being studied now.
Wow, that is amazing. So I've only seen auroras in videos and images. What is it like to see it firsthand?
From my latitude in southern Manitoba, it just looks like a white light, maybe with a green tint to it. When it's active, then sometimes I can see the pink fringe along the bottom, and sometimes I can also see the red that goes high above. But most of the time, it's only about 30 degrees above the horizon where I am. Once in a while, it will go overhead. And it starts with just a low band. If we get to a substorm, then it will start dancing for about 30 seconds to about 20 minutes. And that's the very exciting part that we want to photograph. And after that is a very subtle pulsating aurora that is difficult to actually see with the eyes, but the camera can really capture it beautifully.
That is just amazing. And so we only have a couple seconds left, but do you have a couple pieces of advice for people that want to get involved?
I would say please join us, because it's a very exciting thing to be involved with, to be able to report and share what I see. I'm not a scientist. I don't have a great camera. I'm not a professional, but I can be involved in something that's really important. And right now, in this time of social distancing, we're looking for something to do outside, and we can do this on our own. We don't need to worry about social distancing, and we can link arms with everyone across the globe to be a part of something very exciting like this.
Yeah, virtually we can get together, and also it's really a great bridge between the public and the scientific community, and it spurs a lot of great communication and questions about what we're seeing. So yeah, we encourage people to join us. Be patient. The sun, we have to wait for the sun and the sky to be clear, and that can take a while, but you can join our community and learn more in the meantime. So everyone is welcome.
Awesome. Thank you both so much.
Thank you.
If you're interested in astronomy and looking to the sky, this next project might be for you. The International Astronomical Search Collaboration, also known as ISAC, is a program that allows citizen scientists all around the world to analyze NASA's high-quality data of near-Earth objects, things like asteroids and comets. With this data, volunteers are able to make discoveries of new asteroids in our solar system and near Earth. I'm joined by ISAC founder Dr. Patrick Miller and citizen scientist Ludwig Adolfo Fernandez. Thank you both for joining us.
Yeah, thank you.
So, Patrick, this sounds like an exciting project. Could you tell us more about it?
Yes, we started this project in 2006. I think we had like 5 teams participating. Now we've got over 3,000 teams from 80 countries around the world that participate. We provide images from large telescopes at the University of Hawaii, the Pan-STARRS Sky Survey, and also the University of Arizona, the Catalina Sky Survey. We take these images, we process them, and then send them out to teams of citizen scientists around the world. And their job is to look through these images and find discoveries of asteroids and occasionally near-Earth objects.
Wow, this is really important work. So Ludwig, you've been involved with this project. Can you tell us how you participate and what sort of skills someone would need to get involved?
Well, I manage the campaign for Bolivia. It's named All Bolivian Asteroid Search Campaign. This campaign is pretty new. We are working with ISAC since 2018. To this day, more than 1,000 students participated in the campaign. There isn't like a list of skills to participate, but the student needs to meet some requirements, such as having a computer and having internet connection. Sometimes the school is in charge of that. But the most important is to have the desire to learn and to contribute to observation of asteroids.
Wow, okay. So what kind of observations and discoveries have you been able to make here?
Well, at the Bolivian campaign, we have made more than 400 preliminary asteroids and 7 provisional asteroids. So as Bolivian campaign, we also participated in special campaigns that are competitive among the best 10 teams of the world.
Amazing. So, Dr. Miller, how does the work of citizen scientists help with your research?
The citizen scientists are finding objects that are actually not reported by the large sky surveys. Citizen scientists are able to look at these images and see deeper into the images than the automated detection utilities conducted either by Pan-STARRS or Catalina. So those are important observations because they're finding things that are missed in the original data.
Wow, that is quite incredible. What an important project. And it's very cool that citizen scientists can help with this. So what advice do both of you have for other people that want to get involved here?
Well, from Isaac's point of view, if you'd like to participate, you're welcome to come to our website. And we have a registration form, and the staff and I will be happy to work with you. It takes a day or two once you send in your interests, and then we'll get you set up and participating before you know it. And it's free.
Yeah. For me, is that don't be afraid to apply. It's a great opportunity to make important discoveries in asteroids. So there is a great experience. It's free and it's open for everyone.
Amazing. Great advice. Thank you both so much for the work that you're doing and for being with us here today. So today we have explored our oceans, our skies, and planets that are far, far away. And we've learned that you too can be a scientist from your very own home. Let's see how the kids in this next video have been contributing to NASA research from the place where they live.
NASA has scientists posted all over the world studying Earth's frozen regions. We've got people exploring ice sheets, glaciers, permafrost, sea ice, snow, and even ice on other planets. But even our top scientists need a little backup sometimes.
I'm a scientist!
Do you like going outside to do science?
Yeah,
Why?
because it's fun.
Yeah. What's your favorite part?
Frost tube.
Frost tube! Cool!
We're following the micro-explorers that are helping NASA collect data from their own backyard.
Do you think it's going to be frozen?
Yeah.
Yes? Why?
Because it's very frozen!
Here's the idea. Students construct a frost tube that gets put into a hole in undisturbed and uncompacted soil. During the cold months, students will measure the depth at which water in the frost tube freezes, indicating that the surrounding soil has frozen. This is one of many citizen science projects facilitated by GLOBE, the Global Learning and Observations to Benefit the Environment program.
What's going on? What did you find out?
It's ice!
How far down is the ice? So is there still liquid in there?
It's a worldwide program that, so far, has collected over 130 million measurements from more than 10 million students in 113 countries.
Are you scientists?
Yeah.
These measurements are added to a massive worldwide database that's free and open to the public.
GLOBE connects my students with the rest of the world through science and looking at climate change and how it's affecting the future.
GLOBE teachers like Terry are transforming the way kids see science and how they'll respond to changes in their future environment.
Let me see your happy face.
Thank you all for joining us today to learn about citizen science. If you want to become a citizen scientist yourself, visit science.nasa.gov/citizenscience and explore all of the projects that need you. There's science that can be done by anyone, anywhere, all across the globe with just a cell phone or a laptop. You can also follow Do NASA Science on Twitter and Facebook to stay informed of the latest updates and discoveries. Thank you so much for watching NASA Science Live. Until next time.